Ladies and gentlemen, boys and girls, young and old, welcome to another edition of Tech in 10 with Sin. Today I'm taking a look at Supermicro C7Z170-OCE, one of Supermicro's better attempts at a gaming series motherboard. The aesthetics on this motherboard are super awesome. They're really unique, considering it actually has green aesthetics. The SQ, another motherboard I reviewed on Tweaktown a little while ago, it has red aesthetics, but Supermicro decided to go the extra mile with the OCZ, and you'll see what I'm talking about. It really can compete in terms of looks, features, and performance compared to other Z170 motherboards, and Supermicro has worked really hard to get this board there. Supermicro is known for server motherboards. They're an American company founded in the US, and they design all their boards in the United States. They're designed for servers, so that means 24 hours a day, 7 days a week, 365 days a year, the motherboard has to be on and chugging away. Chugging away, but not only at idle, but at 100%. That means quality of the components has to be top notch. And that also means that if the same design practices are used for a consumer board, that consumer board should overclock tremendously, and it should perform quite well and maintain pretty good thermals to basically provide that kind of long-term durability. Now, the box is quite simple. I love how Supermicro has gone with the brushed aluminum look on their cardboard on the front. I really love the edges of the motherboard. The back of the board is nothing until you remove this. This little cover keeps it together. So we got some features going on here. There are a bunch of features, and I really don't like reading features, but I guess maybe an unboxing should include that. So it supports the latest processors, Z170, non-UCC 64 gigs. Something interesting though, the PCIe expansion slots. This board has a PLX 8747, and this motherboard is supposed to come in at $300. $299.99 is the MSRP as per my contact at Supermicro. That makes it the most affordable motherboard with a PEX A747. It supports 3-way SLI, which is much more likely to occur than 4-way SLI on the Z170 platform, pretty much because you want a much better CPU if you're going to go that high in terms of gaming performance. Now, this is only a 3-way SLI board, while some motherboards with the PLX A747 can do 4-way, but I guess Supermicro decided to go for this for spacing constraints. I'll talk about later the benefits of going with 3/4. I mean, yeah, you do lose the ability to say, oh, I support 4-way SLI, but you do kind of gain some abilities to fit larger coolers, to stay within a form factor, and to provide better spacing between the GPUs. I/O ports, USB 3.1 check, and check again. And check again and again, because there are a possibility of almost 4 USB 3.1 ports, but actually only 2 are officially supported. But the internal USB 3.0 header actually uses a 3.1 controller, so you might be able to see higher speeds over those ports. Anyways, even though I don't think that's the USB 3.1 spec, but you should see decent performance. There are 2 controllers. Display ports, you get DisplayPort 1.2, DVI, and HDMI 2.0. 1 PS2 port, kind of unimportant. 2 Intel NICs. This is a big deal for a lot of people. A lot of people care to have 2 Intel NICs. I don't really care for more than 1 NIC, but for my personal use. For servers and high-end platforms, yeah, sure, you can team NICs. That's awesome. But personally, I just use 1. But having 2 is a big bonus, especially for those who want to double team it, you know? So it does support overclocking, and here's something else. It supports non-K SKU overclocking. If you might recall, Supermicro was the first motherboard vendor to come out with non-K SKU overclocking. Then all the other vendors copied them. Supermicro was the one who hacked the UEFI code from Intel, and was the one who came out with the first non-K overclocking. They did it not only on Z series, but also on their H series board is when they first leaked it, and it totally blew everyone away and got people super duper excited. Let me show you Supermicro's latest offering, and I'm going to show you how to actually overclock a non-K SKU with this motherboard. So that's going to be a goodie for this review I haven't really done before. So let's take a look at the accessories. The board comes in here. I've already opened it before. There's actually a silicone package in there to suck up humidity and moisture, so there's not going to be any of that existing to damage electronics. Another practice not common in the consumer board market, but very common in a server market. 6 red SATA cables, and you're thinking, why would they give me red instead of black or green? Well, the LEDs on the motherboard are red, so actually from seeing the board installed and operating, it actually does match red components because the LEDs are red. you have your DVDs. You also have a quick start manual. This is actually useful to finding out what all the jumpers are, and if you've never installed the CPU, it tells you how to do it. Shows you the pinout, shows you what all the buttons and jumpers do. Let me see if you can zoom in, if you can even read this. Yeah, now you should be able to read it. So you have all these buttons and jumpers and installing the CPU and the motherboard, the layout and all that. I'm going to go over it. It's going to be better than this manual. One thing to notice, there are only so many accessories, just these and this I/O shield. I'm going to keep the zoom up here. And if you look closely on the I/O shield, you will actually see that this seems to have been laser etched. So it looks like Supermicro has actually used laser etching to etch in the symbols on the I/O shield, which is quite neat and a little bit awesome. I actually kind of like it, even though I don't really stare at the I/O shield all too much. I do like the effort pointing to detail, and I actually saw no mention of this in their marketing, so it might not be laser etched, and I might just be making that up, but I don't think so. It looks laser etched because the aluminum looks like it's been specifically designed to read out what everything does. The motherboard. It is beautiful, actually. I really like this shade of green. I've talked to a few people and they either love it or they hate it. I love green motherboards. I don't know. I mean, when I was growing up, DFI was a big brand. Great brand. Brand I could never personally afford, and my parents wouldn't buy it for me. So I was always stuck with something like an 8-bit, which actually were awesome performers, or an Asus. And I really always wanted a green or an orange UV reactive slot motherboard. It's just something I wanted when I was younger, and to this day I kind of still do. No one has come out with a UV reactive slot scheme yet, but Supermicro seems like they might, because they have totally jumped over into the realm of making things look pretty. And looking pretty is part of the game, right? People talk about overclocking and tuning computers just like cars. Well, what's so wrong about making the motherboards and computers look nice while people go and make their cars look so pretty? Why can't I do the same for my motherboard, right? Anyways, forget the little side note, but let's look at the motherboard, right? So you have a really nice voltage regulator. The VRM here is high quality, uses server grade components. It also uses really high current capability chokes. The DIMMs are green, and there are buttons here. I guess I should talk about the buttons right now. Maybe I'll start from this side of the board. I've actually soldered wires on the other side. There's only one overclocking feature this motherboard's really missing that I really wanted, and that is voltage read points, but I made my own. Anyways, you have an 8-pin power for the CPU. As you can see, Supermicro has actually made sure that the fan headers are green. That's something new. It's rare to find fan headers that are specifically colored, and that's because it's expensive to basically contract out obtaining these fan headers like that. Then we have, we're moving over here. Here we have some OC features, and let me talk about what they do. So you basically have your clear CMOS. Well, let me get a good zoom on that, and I can let go and show you what everything does. There's some weird symbols over some of them, and I'll show you what Supermicro is trying to do, because it's a little odd. So you have your fan header here. All the fan headers are PWM fan headers. I believe there are 1, 2, 3, 4, 5. Yeah, 5 sounds correct. Clear CMOS button is this one here. Okay, and we'll click that now. And then this is a BIOS restoration button. So like USB flashback, this motherboard does it. And then this is a power button. I don't know what symbol this means power to most people. Maybe it looks like a 1 coming from this direction if you're looking at the motherboard installed in the case. However, these buttons are all facing me at this view. So this just looks like a dash to me. But it does look like a 1 if you're looking at it when the motherboard is installed. This is a home button. This should load defaults and take you to the BIOS. Motorcycle button will give you a 10% OC. This is a race car button. That'll give you, I think, 15 to 25% OC, something like that. The jet button will load a preset. This is actually referred to as OC2. The jet is OC. This is OC3 is the jet. OC2 is the car. OC1 is the motorcycle. OC3/jet is actually a preset profile that you can set in the UEFI yourself. So you put your profile in the UEFI and the motherboard will basically run it for you. The M here is a memory overclock. I'm guessing something like XMP or something else. I never tried it. Going over here, another fan header, a right-angled USB 3.0 header, which is actually quite rare because it is an expensive part to source. Moving over, we have a bunch of SATA ports, and these SATA ports are green as well, right-angled, and this color green actually matches the heatsink color green much better than the video lets it show. There's 6. Okay, all from the PCH. Moving over, there is a built-in buzzer because this is a server grade board and servers have built-in buzzers because the buzzer beep codes are quite important. Got your postcode display. This is super duper important. SATA DOM power for certain SATA devices. This would be power for them. And then you have headers down here. There is a USB header over here. And this USB header over here, these are like front panel headers, trusted platform module headers, COM ports. I believe this is perhaps USB 2.0. Actually, judging by this chip right next to it, this might be a COM port. You can look at the manual for that. Anyways, this is USB 3.0. This is actually USB 3.1 controller. Same as used on the back, but USB 3.1 specification does not really allow for this type of header. I don't think. I don't know what for the internal header, but I would think it's different because the signaling is so much, it double the speed, and it was hard enough to do that. It was hard enough to get good signaling out of this at 5 gigabits per second. At 10 gigabits per second, which is basically the speed of 2 PCIe lanes over copper, I would assume that this type of header might not be good enough, and maybe that's why a lot of motherboard makers are using SATA Express to get USB 3.1 to the front panel. Nevertheless, they are not advertising this port as USB 3.1. Instead, they are advertising it as USB 3.0 from a USB 3.1 controller, so maybe you will get superior bandwidth compared to other USB 3.0 internal headers. Yes, these are USB 2.0. This must be a COM because this is a drivers and receivers chip, so yeah. This is a lock button for BIOS flashback, so you either enable or disable recovery mode. It's kind of weird to have both the button over there and this switch, but this basically unlocks it. So that switch I don't think does anything until you basically turn this switch on. Jumpers over here for disabling. Actually, there are jumpers everywhere on the board for disabling basically every controller, and that is awesome. These are your audio output headers, high definition audio. You see that line over the PCB, just like other motherboards. That line is responsible for dividing the analog and digital domains, so there's no crossover into anything, into the signal, so your analog signals don't get distorted from EMI or anything like that from the rest of the board. Super O is their new name for the gaming series of Supermicro, and you see this black plastic shield. It's plastic, right? Yeah, plastic, but it kind of feels like metal. Has been added to cover up the silver of the I/O ports, and that is awesome. The capacitors are basically blue and silver. I would have liked to see these be black, but you know, there's always next time. In the middle here is a PLX 8747 bridge. Now, this bridge is quite important. It takes 16x from the CPU and distributes it down to the PCIe slots. So let's open up here and take a look. So we have 4 PCIe slots, and it might be a little confusing. So let me go over it, how everything is done. So you basically have this slot. This slot is hardwired to the PEX 8747. So, yeah, so this directly is hooked up to this. So when 16 lanes come from the CPU to the PEX 8747, it takes those 16x lanes and basically corresponds them to 32x down here at these 3 slots. The long slots get 32x, but in a pretty interesting way. So there are 4 ASM 1480s here. Each one is a PCIe 3.0 2x switch. So 4 of them all together switch 8x of bandwidth. Now, 16x here, and this slot can also run 16x. So 2 GPUs, one here and one here, will both run at 16x. And so you have extra spacing between the GPUs on purpose. Plus, they're shifted down 1 slot from normal PLX 8747 configurations and large coolers like the NH-G15 from Noctua that do not fit at all on other PX 8747 boards, especially with GPUs that have backplates, will fit just fine on this motherboard with GPUs with backplates. So basically this is how the PCIe works. 16x, 16x, or 16x, 8x, 8x. These 4 switches switch the 8x here up to here. even though there are pins in all of these slots, these last 8 pins don't do much, but the bandwidth from this 8x can be switched here. This is always hardwired 16x. So this always runs a 16x and probably has lower latency than these two slots, just slightly lower. However, these two will be 16-16 and then 16-8-8, or you could actually do 16 and 8 and not do anything here. This will still get 8 if it's used. This will always go down to 8 if this is used. So basically 16-8-8 or 16-16. Sorry for doing it so many times, just wanted to get away from the confusion that my words might add. So these 4x slots are actually 1x direct to the PCH. It might be a little bit deceiving to have this size slot here, but it's to basically support 4x devices in a 1x of bandwidth. So the larger slot here provides more structural support for the device. If you just had a 1x slot here, part of it will be hanging out, and if it has a 4x connection, it might alter things. So there are a lot of devices such as PCIe based storage that are 4x, and those would fit here but only get 1x of bandwidth, which isn't a really big deal. You have M.2 right here. This is at 32 gigabits per second, and I think the beauty of this is that it's not hooked up to anything. This only will support NVMe based drives. It's only supporting PCIe based M.2 drives. So if you have a SATA based M.2 drive, which actually uses a SATA protocol instead of PCIe, which is really what all the faster drives use, like an Intel 530 series, then it won't work in this M.2 slot. But let's say you have a Predator from HyperX, that will work here. Sure. Samsung's XP941 will work. Samsung's SM950 and 951 will work. The 950 Pro will work. And Intel 750 through U.2 will also work in here. And here's the beauty of this. The PCH is limited to about 4 gigabytes per second of bandwidth going up there. In true results, I have a friend, he took 2 950s and he rated them in M.2, and the DMI limited him to 3.5 gigabytes per second because of the DMI. Now, using the PLX A747, get this. Here's something really cool you could do. GPU here, and 8x PCIe 3.0 here for a really fast NVMe based storage drive. So you could toss a M.2 drive into a PCIe adapter, or like Intel 750 edition PCIe type drive will fit in here by default, and it will run through the CPU and not bottlenecked by the DMI and not bottleneck bandwidth of other devices, and that is awesome. That is another really great use for the PX A747 on this platform, with the PX on this platform basically. Sorry. So yeah, battery right here. You might need to remove this to clear the CMOS. I've tried the button a few times, but you really do need to take the battery out. There's also a BIOS ROM here, and this BIOS ROM can be taken out and replaced in case something happens to it. Hopefully nothing will happen to it, because that'd be a real bummer. Yeah, let's look at the back panel. Oh, I've soldered stuff on the back for voltage read for the second part of this review. Anyways, here's the I.O. The I.O. is pretty hefty. It's pretty nice. It's a little low on normal USB Type A, but that's not a really big deal. USB 2.0, USB 2.0, PS2 keyboard or mouse, S/PDIF optical, or actually this is called digital. Optical is the actual coaxial cable. Gold-plated HDMI, this is HDMI 2.0 gold-plated. DisplayPort 1.2 gold-plated. DVI output. Dual Intel NICs. This is pretty cool, right? One of the biggest selling features. 2 USB 3.0 and a single USB 3.1 Type-C connector. So this is the latest and greatest in USB connectivity. And then you have 7.1 output from the ALC 1150. Let's take the heat sinks off, shall we? I know people are waiting for this part. So I've gone and I have basically soldered some wires to the output capacitor. I hope I didn't screw it up by doing this review. No, it should be okay. Let's make sure the wires don't move around. Okay, yeah, it's fine. So basically, any of these output capacitors here, and here. And if you want to be really, really precise, you can go actually underneath the socket, but it's hard to solder there. You don't really need to solder. In a case, a lot of cases have cutouts in the back, and you could just take a digital multimeter with needle tip points, and you can get what you need that way. But yeah, so you basically just want to go to an output capacitor that from the CPU phases, which are these 6, and you want to go plus and minus on either leg, and that'll give you the closest voltage to real V-core. And this is a JTAG connector. Don't worry about that. This is an engineering sample board, so you won't have that on yours. I do want to show you something else, the LEDs on the back. Supermicro's LED selection is pretty good. It is these are quite powerful LEDs. They are red. So you have a few of them here. 1, 2, 3, 4, 5, 6, 7, 8, 9 red LEDs. And there are other parts of the board that are red as well. So LEDs are, I mean, it's good to have red on red. Now, let's get to unscrewing the heat sinks, because that's important as well. All the heat sinks on this motherboard are actually screwed in, which is an awesome thing, because before Supermicro wasn't using screws. So I'm going to take off the shield as well at the same time. Yeah, Supermicro used to just use push pins because that's what typically is done on servers, because they're never removed, the heatsink never removes them. Push pins do an okay job. Not the best. I prefer screws. I feel like screws do a much better job of maintaining the integrity of the connection. Sometimes when you take screws out, the actual screw doesn't come out. Instead, it unscrews out of the heatsink, and you'll see what I mean because it just happened. Yeah. So actually the screws for the VRM part are a little different than the screws for the rest of the motherboard. They seem to come out better and detach better. Oh, there are washers. I'll make sure to put the washers back. But yeah, I basically soldered in the wires. You can also do the same thing with the output capacitors for the DRAM voltage, for anything that has a voltage regulator on the motherboard. So VCSA, VCIO controllers also have output capacitors. They're right around here-ish. I believe here, and here. And you can measure voltages there. See, all of the heatsinks came out, and some of the brackets for those heatsinks did too. This is for the M.2. So this is the PCH, not the PCH, the PLX heatsink. This cools the 8 watt or 7 watt PLX A747. It's a hot chip. The PCH actually runs a little cooler than the PX A747, and contact is pretty good there too. Contact on this heatsink is very good against the VRM, and this is a pretty good heatsink. It is bulky, it is heavy, and it is good looking. The thermal pad actually came off this heatsink on the VRM, so I'm going to put that thermal pad back on. Thermal pads do not glue. They're meant to come off quite easily, and they don't conduct. But yeah, so this one came off a little bit. But we just put it back on there, and that's all good. So contact on this was good as well. Now, the shield on the inside is just plastic, but all the shields from all manufacturers are plastic. Only 1 or 2 manufacturers actually uses metal shields. People actually prefer plastic, less chance of shorting out something. So, like I said, you'll see that some parts of the screws come out from the heatsink. I mean, yeah, from the heatsinks, but others don't. Look at the PLX A747. The standoffs, the standoffs didn't come off, but the heatsink did. They actually unscrewed out of the heatsink. So here, they just straight up unscrewed out of the heatsink. This happens on many boards. You can actually take pliers, hold it down, unscrew the screws, and screw this back into heatsinks. But really, what's the difference, right? The same amount is going to be re-screwed into it. The same amount of pressure is going to be applied, so not a big deal. PX8747, not removing the thermal paste. There's no reason to. We know what it is. And I've already taken pictures from my review. And I guess we should start from the VRM portion, right? Just like I always do. There are 2... IR PWMs, one here and one here. These are IR 35203s. I believe they're 6-phase PWMs. I'm going to try to get closer so we can get a better angle and you can see, actually, maybe even read some of the parts. Yeah, that's probably the best I can do at this point. Okay, so we have 2 IR 35203, latest in IR digital PWM circuitry for Skylake. This is a very popular PWM. I believe this is a 6-phase or maybe a 4+2. I don't know. IR has not released data sheets. All I know for sure is that the IR 35201 actually has 6+2 phases and has 14 pins on each side. This has 12 pins on each side and is an IR35203. Higher number does not mean a higher phase count. Many times it means less. In this case, I believe it's just a straight 6-phase. It doesn't have the extra +2. And that is warranted because the CPU VRM, which is right here, all these phases only output CPU power. So, each of these is an IR3556M. 50 amp power stage. That is high quality. These are Vitec. These I believe are 50 amp or 55 amp output eye saturation, less saturation current for each FET. These will run much cooler because there's no way you're pulling 50 amps per phase, which is what this motherboard is capable of. These are capacitors. They're solid polymers. I don't know the hours, but I would guess maybe 5K. Something like that. It's not important. It's probably 5K though. Looking at some of these parts, this is an ASM 1442, a level shifter. A level shifter basically changes the output from display or digital video, which is native to DisplayPort, to basically something that DVI and HDMI can use. There also needs to be an Intel NIC, and that is right here. This is actually the PHY, which is a physical layer device, and the PHY is basically it works with the gigabit integrated LAN inside the PCH. So it's the i219V. This is an AS Media 1442, and these two are extra for the USB 3.1. This is a USB 3.1 controller for the USB Type-C on the back. Intel WIG210AT. This is a gigabit NIC. This is all NIC, so there's no integrated MAC and then a discrete physical layer device. Instead, this is all in one. Here we have the audio, Realtek ALC 1150. Now there is no amplifier here. However, audio results were quite good, almost as good as some boards with the amplifier. It's not a big deal that it's not there, but that would be something Supermicro could improve on. Oh, and the O lights up with those two LEDs we took a look at earlier. Okay, so let's take a look at, what haven't I covered? Okay, so let's take a look here closer at this USB 3.1 controller that I mentioned. So this is an ASM 1442, same as the back panel for the USB 3.1 Type-C, but instead here you see it doesn't have those two USB 3.1 power chips that help sustain the Type-C switch, which are here. Those are not present here because this is a USB 3.0 internal header. This is drivers and receiver. Nuvoton Super I/O. This is a NCT 6792D, pretty common. This is a solid state clock gen, like crystal, but not really. What else? What else? Oh, all the 6 SATA ports will not be switched with the M.2, so they work independently like I mentioned earlier. This is power delivery for the PCH. Here we have some power delivery. This is a 10 amp Texas Instruments chip. I actually might have written down what it is. TPS 51362, it's a 10 amp buck, and it's basically integrated voltage regulator, and then this is a single phase. Going over for these phases for the memory, Primerion PWM from Infineon digital, and a single phase power stage, same 55 amp, and then these are 50 amp IR3550s. There's also a clock generator here for discrete base clock clocking. Okay, so now I'm going to end this, and thank you for watching. Now please continue to watch part 2.